Okay, so I'm going to be continuing with every exam question that has ever been asked, and we're going to do it now on sequences. So if you do want this document is available in the description, and it's all fully hyperlinked, which takes you around to all the different bits. So there are the four kind of subtopics for this. We've got linear, quadratic, geometric, and then Fibonacci, but most of them are quadratic. There's actually only one linear, one geometric, and one Fibonacci, even after all these years of exams. So I'm going to start off with linear sequences that we've got here, and it just says the first 5 terms of an arithmetic sequence are 1, 4, 7, 10 and 13. Write down an expression in terms of n for the nth term of this sequence. Well, the first thing that we're spotting with this thing that we've got here is that it's going up in threes. So because it's going up in threes, that means it's going to be a 3n. And the technique that I do is I say, what would be the number that would come before? And the number that would become before this would be a minus 2. So we just put the minus 2 on afterwards, meaning that the nth term is 3n minus 2. And there it is. Now we're going to have a look at this one, which is about generating quadratic sequences. Now this is a calculator one, so we probably will use a calculator to make this a bit easier. So it says the nth term of a sequence is 2n squared minus 1, and the nth term of a different sequence is 40 minus n squared. Show that there is only one number that is in both of these sequences. So it doesn't actually make sense to do 2n squared minus 1 equals 40 minus n squared, because that would be finding when the sequences have got the same value and what position that would be in, but they might not be in the same position for each of them. So instead what we're going to do is just generate the sequences separately. So we're going to look at the 2n squared minus 1, and we're going to just use the calculator to substitute this in. Now what you could do is you could use the table mode, but I'm just going to do it in the sort of regular mode for this. So I'm going to do 2 brackets, and inside my brackets is where I'm going to put my value of n, and that's going to be squared minus 1. So I'm going to start off by putting in position 1, figure out what that's going to be. So we get the first number is 1. I'm then just going to change that and put 2, and then becomes 7. I'll change it and becomes 3, 4, 5, and maybe we'll stop at 6. So it's literally just getting these things typed into the calculator. Now I'm going to do my 40 minus n squared. So I'm going to clear that, and I'm going to instead do 40 minus, I'll put a bracket around it, and I'll do that squared. I'm going to start off with 1, so I get 39. Whoops, I meant to just do, keeping the brackets there. But I'm going to do 40 minus 2 squared, which is 36. I'm going to change that to a 3, and so we get 31. Now we can already see that we've got the ones matching, but if I keep going here, we get 24, 15, and just for the symmetry of doing 6 of each of them, I get 4. So 31 is in both sequences. And we can see this sequence is just getting smaller and smaller, so there's not going to be a one that's matching because this one is getting bigger and bigger. So we've got most these bits here, and we've said that we've got 31 that's in both of them for generating at least 3 in each sequence and doing the sum from each of them, okay? So, actually I wanted quite a few of them here. We wanted to do 39 all the way down to 4 and 1 all the way to 49, just to show that it was increasing. Okay, this is a calculator one. Now there's kind of 2 methods of finding the nth term of this sequence. This is a quadratic sequence. I'm going to do, for the first 2 questions, I'm going to do the method that I prefer, and then I'm going to show you a different method for the next 2 or 3 of them. So when I do these, I'm just going to start off by finding the first and second differences, which is what they pretty much all begin with. So the first difference between 4 and 11 is 7, 11 and 22 is 11, 22 and 37 is 15, and 37 and 56 is 19. Between 7 and 11 is 4, 11 and 15 is 4, and 15 is 19 is 4. Now these different things are going to correspond to different values. This one is going to be 2a. This one is going to be 3a plus b, and this one is going to be a plus b plus c. So what we're going to do here is we are going to use these to solve them. So we're going to say that 2a is equal to 4 from the one that we have at the bottom, which means that a is equal to 2. By the way, these bits that I've done in red, they're corresponding to my an squared plus bn plus c. We're going to try and find out what a, b and c are for this. Now I know that a is equal to 2. I've got 3a plus b, so that's 3 multiplied by 2 plus b equals 7. So that's 6 plus b equals 7, which means that b is equal to 1. And then we know that a plus b plus c is equal to 4. So that's a plus b plus c is equal to 4, which means that c is equal to 1. So just using that part that I've got written in red, that is 2n squared plus 1n plus 1. So this is the nth term of the quadratic. Now I've got some playlists that explain where this comes from, but these bits in red here do need to be memorised if you want to be able to use this method. So let's double check we've got this right. We've got 2n squared plus n plus 1. Perfect. Okay, I'm going to do this one again. So we've got our minus 1, 5, 15, 29, 47 and 69, and we're going to do the same process. The difference between these is 6, then the difference is 10, then 14, then 18, and then 22, and their differences are 4, 4, 4, and 4. So remember, this one here is what 2a is equal to. This one is 3a plus b, and this one is a plus b plus c, and that's to give us an squared plus bn plus c. So 2a is equal to 4. If 2a is equal to 4, that just means that a is equal to 2. Now we've got 3a plus b equals 6, so that is 3 times a plus b equals 6. So that's 6 plus b equals 6. That must mean b is equal to 0. And then we have a plus b plus c is equal to minus 1. I should have my little equal sign on that bit. So we get a plus b plus c is equal to minus 1. So that must mean when I do minus 1 minus 2 is minus 3. So putting that all back together, we get 2n squared, we get no n's, and we just get minus 3. Great, we've got the 2n squared minus 3 for this one. So I'm going to show you the slightly different one for this, okay? We're going to do the comparing the sequences. So we're going to start off in the same way, where we have finding the second difference. So that's 1, 3, 5, and 7, which means it goes up by 2 each time. Now we still need to use the fact here that this is going to say that the a coefficient, 2a is equal to 2, so the a coefficient is 1. In other words, we know it's going to be something to do with n squared. So what we do is we write down our sequence, then we write down the n squared sequence, and we're going to compare them. So the n squared sequence would go 1, then it would go 4, that's 2 squared, then 3 squared, then 4 squared, then 5 squared. And then all we're going to do is subtract them and see what the nth term is of that sequence. So minus 1 is minus 2, 0 minus 4 is minus 4, 3 minus 9 is minus 6, we then get minus 8, and we get minus 10. Now all we need to do is just find the nth term of this sequence. Well, it's going down 2 each time, so it would be minus 2n, and the previous term would have been a 0, so it's minus 2n plus 0. So putting that all together, you just take this part, and that becomes your nth term. So it is just n squared minus 2n plus 0, but obviously we're not going to write plus 0, so we're just going to write n squared minus 2n. So you can decide which one you prefer of these. Again, like I said before, I've got like a full playlist teaching this. This is not for me teaching it, it's just me giving you the answers and reminding you how to do them. So we do have our n squared minus 2n. Okay, we're going to do that other technique. So I'm going to very quickly just do the first and second differences. I'll sort of squeeze them in under here. So 10 and 21 is 11. 21 and 38 goes up 17. This is going to be going up 23, and this is going to be going up 29. So the second difference is 6, 6, and 6. So remember, that is that 2a is equal to 6. So a is equal to 3, meaning it is a 3n squared. So I'm going to start with our sequence, and our sequence that we've got is 10, 21, 38, 61. That's enough. I don't need to do all of them. And now I'm going to do the 3n squared. So you're going to do substitute in 1, then 2, then 3, then 4. So 1 squared is 1 and times it by 3. 2 squared is 4 and times it by 3. 3 squared is 9 and times it by 3. And 4 squared is 16. And 16 times 3, obviously you can check it on a calculator, is 48. So then we subtract these. 10 take away 3 is 7. 21 take away 12 is 9. 38 take away 27 is 11. And 61 take away 48 is 13. So all we need to do now is find the nth term of this, Well, it's going up in 2's each time, so it's 2n, and the previous number would have been a 5. So we simply take these parts here and we write that all together for the nth term. So it's going to be 3n squared plus 2n plus 5. Now, like I said, you could use either of these methods, but this bit that we've got down here is going to be the one that we have, 3n squared plus 2n plus 5. Okay, this time we have something that's a little bit different. It says quadratic sequences and simultaneous equations. The nth term of a sequence is given by this, where a and b are integers. The second term is -2, and the fourth term is 12. Find the sixth term of the sequence. So the second term means that n is 2, and the fourth term means that n is 4. So I'm going to begin by substituting 2 into this expression that we've got at the top. Well, n squared, 2 squared would be 4, so I have 4a. And then that is multiplying b by 2, which is 2b. So that's what the sequence is, and it says that it's equal to -2. Now, if I substitute 4 in here, I'm going to get 4 squared times a, which is 16a. And then when I substitute 4 in here, I'm going to get plus 4b. Now, we can't solve these in the way that they are because of the different coefficients. So I'm going to take, doesn't really matter which one, I'm going to take the top one and I'm going to make the a's match each other, or I can make the b's match each other. So actually, you know what, let's make the b's match each other. So I'm going to take this equation and I'm going to double it. So when I double it, I get 8a plus 4b equals -4. And then the other equation is still 16a plus 4b equals 12. Now we're going to subtract them to get rid of these 4b's. So 8a take away 16a, that's -8a. And -4 take away 12 is -16. So I'm going to divide -16 by -8, and that gives me that a is 2. And then I just need to use one of these equations to figure out what b is. So if a is equal to 2, we would have 4 times a, 4 times 2, that's 8. 8 plus 2b is -2. I'm going to subtract the 8, so I get -2 minus 8, and -2 minus 8 is -10. Why have I suddenly changed that to an 8 in front of the b? No wonder I was confused. So 2b is -10, which means b is -5. Now I'm actually going to take some of this and I'm going to see if I can squeeze it in a little bit tighter, because I'm going to run out of space for the last part of the question. So now we know what a and b are, we're going to find out what the sixth term is. So the sixth term is going to be equal to replacing it with a 6. So it is going to be 2 times 6 squared plus, or -5, because it's b, -5 times 6. So I'm going to just type that in on my calculator. I'm going to do 2 times 6 squared minus 5 times 6, and we get that the sixth term is 42. I've really had to squeeze that in here. So this is that n is equal to 6 for the sixth term. And the last one, it says, here are the first 5 terms of a different quadratic sequence. Find an expression for the nth term. So let's see if we can see what it's going up in. It's going up in 2, then 4, then 6, then 8. Okay, that means the second differences are 2, 2, and 2. So 2a is equal to 2, which means a is 1. So it's going to be an n squared sequence. So our sequence goes, really having to squeeze this in, it goes 0, 2, 6, 12. The n squared goes 1, 4, 9, 16. And when we subtract them, we'll see what we get. So 0 minus 1, 2 minus 4, 6 minus 9, 12 minus 16. Well, it's going down in ones, so it's minus n, and the previous one would have been a 0. So it's actually just going to be n squared minus n for the nth term. I'll tell you what I'm going to do here. I'm just going to block that part out so it's clear that it's belonging to the previous question that we've got. Okay? So the nth term is n squared minus n, and the previous one, the sixth term, is 42. So we do have 42 and n squared minus n, and we got that a was 2 and b was -5. Apologies if I have had to kind of squeeze that one in there. So I think we've just got two last questions. We've got this one on geometric sequences and surds. So we've got this geometric sequence here, and it says that it's root x minus 1, 1, and root x plus 1, and they have first 3 terms of s. we're going to find the value of x, and we're going to show all of our working. Now, I've actually done this one in the surds topic, but a geometric sequence is something like this, maybe 2, 6, 18. It's multiplying by something each time. Now, if you wanted to find this out, we could, to find out what it's multiplying by each time, you could do this one divided by the one before, and we know that that would have to be the same as 18 divided by the one before. So 6 divided by 2 is the same as 18 divided by 6. So I'm just going to erase that, because, well, I'll erase that at the end. We don't need to have that part. So we're going to say that 1, when you divide it by the previous one, 1 divided by the square root of x minus 1, must be the same as the square root of x plus 1 divided by 1. So I'm saying if it's divided by 1, it's kind of not really going to matter at all. So I'm going to be able to get rid of that in just a second. And I'm just going to multiply up by the root x minus 1. So I get root x plus 1, and that's going to multiply by root x minus 1. This 1 just kind of goes. So I'm going to expand the brackets on the right side. Root x times root x is x. Root x times minus 1 is minus root x. 1 times root x is root x. And then I get minus 1 over here. These parts cancel, which just tells me I need to add the 1 to the other side, and so x is equal to 2. Then it wants us to show that the fifth term is this that we've got here. Well, I guess we can actually find out what it's multiplying by each time. This is what it's multiplying by each time. So each time it multiplies by root x plus 1, which is root 2 plus 1. Now, our first term, we could say, our first term is root 2 minus 1. Now, we want to find out the fifth term. So the fifth term is going to be the first term, and this is what we multiply it by each time. We're going to multiply it by root 2 plus 1. That would get me the second term. To get the third, fourth, and fifth, I need to multiply it by that 4 times. And I can literally just type that on my calculator, and it's going to give me the answer. Now, when I did this in the surds video, I decided to do it sort of a longer way, but we can actually do it really quick if we just do it on the calculator. So I'm going to do root 2 minus 1, that is the first term, and each time it is getting multiplied by root 2 plus 1, and that is happening 4 times, so I'm going to do that to the power of 4. And I'm going to press SD, and we get the answer 7 plus 5 root 2. Now, although it says show this, well, we have shown it because this is the calculation. It's a calculator paper, so we can leave it in that form. Okay, last one that we've got here. There it is with our 2 and showing that it's right. The last one we've got is about a Fibonacci sequence. Now, the Fibonacci sequence is one that goes like this. It starts with 1, 1, and then 2. And to find the next one, you add the 2 previous. So the 1 and the 2 makes the 3, the 2 and the 3 makes a 5, the 3 and the 5 would make an 8. That's how a Fibonacci sequence works. So this one says that the sum of the first 5 terms is 228. Well, we've got 1, 2, 3, 4. We just need to find the fifth one, which is by adding these together, and it gives us 8a. So the sum of these is going to be a plus 2a plus 3a, because sum means add, plus 5a plus 8a, and that is equal to 228. So adding those up on the left-hand side, I have 8 plus 5, that's 13, plus 3 is 16, plus 2 is 18, plus the 1 is 19. Now, of course, you could check that on a calculator. So 19a is 228. So a is 228 divided by 19. Of course, I'm going to do that on my calculator. 228 divided by 19, a is equal to 12. Now, the Fibonacci sequence is this. It doesn't have to start with a 1 and a 1. That's just traditionally how it would start. It could, in this case, started with a 12 and then a 24, and then you can see how that pattern would go from there. So we do have the answer 12 for this one. So that's every question that has been asked on sequences. I think you're going to see that it's mostly quadratics. So you better make sure that you know how to do a method. Make sure you decide whether you prefer this comparing method or whether you like this one where you're doing the ABC, the 3a plus b, and the 2a. If you find this helpful, please make sure you share this with your friends. It should be something that would be really useful in the build up to your exams. And I've also got loads of other things on my channel, so do go and check out the main page because there's lots of other videos and more to be coming soon.